Okay, so this is just a walkthrough on how to produce a very simple M12 bolt. That's going to be within a Fusion 360, or the new name for Autodesk Fusion if it's on a newer system. So we're going to use the lines of here that we know how to use the interface, and what we're going to do is I've placed the image that I want to create in here. So I'm just going to zoom in and place. This is going to be our sort of 2D sketch of what we're going to design. And for this process, it's going to be a additive remit. So we're going to add essentially the blocks together to build up our little hex bolt. So what we're going to do is everything we focus around our datum point, which is this point in the middle here. And if I press on the house, we get our 3D space where we can then draw in across the x-axis, which is the red line, the y-axis, which is the green line, and then there's a blue line which will appear in a second, which represents our Z. So we're going to draw this as a actual bolt. So we're going to draw it from the top looking down. So I'm going to first of all click on the top viewpoint on my cube. This will spin round. It will hide my little 2D image. I'm going to come from my datum space. So if you're in the design workspace, under solid, the first thing we're going to do is to create a sketch function, which is normally symbolized by the green plus and the shadow dots behind. And select my top plane, which will be the square you can see highlighted in blue, and that will then zoom in and that will bring the interface to the middle. This will then move from a solid toolbar into the sketch plane, which then you can got the create bar, modify your constraints, and any configurations and inspection. So I could draw a hexagon with some series of lines. I could use a rectangle and trim it back, or you can come to the create bar, come down to polygon, look at circumscribed within a polygon, which uses a center point, or you can use inscribed, which basically uses a center point to a vertex. It's up to you. Both ways are very similar. So I'm going to choose the within a polygon shape, and it's going to be subscribed around. So we're going to choose that one. Now I get the little arrowhead, so I'm going to place on my center point, which is my datum. Click once, and I'm just going to move out my polygon. Down here is the edge number. So if you've got obviously 8, you can change that to 8. It would then change to an octagon. You could then choose 5, change it to a pentagon, or you can then put 11 if you wanted 11 sides, all the way down to 3, which would be a triangle, or 2, which then go back to being a circle because it's nothing's under 3 on a polygon. 4 will give you a square. Obviously 5 pentagon. 6 will be our hexagon, which is what we want to use. What this does is it goes from the center point to the outer edge. So what I'm going to do is tab over to that, and a M12 bolt has a head size across the flats, so either sides of flat to flat of 19 mil. So we put 19 in. Now that's 19 obviously going to be radius, so we know that we need to work out it's 19 on the diameter. So if you're not very good with maths, you could put the slash 2, and that will change it down to then the correct value of 9.5, or if you knew that obviously 19, 9.5, you're good to go there. So that's kind of my hexagonal shape, and quite simply you can just finish the sketch, because that's our sketch now complete. Come back to the home, and there's the first part of our element. So that's our 2D space done, and I'm going to say create bar and use the extrude function here. And you've got very good eyesight on our drawing. It says we need to pull this out 7.5, and there's an actual small little diameter there, which is going to be 0.5 mil. So we pull it up to 7. So put 7 in here. That'll extrude it up to 7 for me. And most importantly, remember to use the create a new body function here, not intercept or any others, just a new one, like so. Then looking at our drawing, there's this kind of circle, which is a 0.5, which is just around the outside. So again, I'm going to click on the top to make it go blue, click on new sketch up here, and I'm going to take a circle diameter, push it out to 19 here, finish my sketch, back to my solid, extrude, click on the circle, and I'm going to do 0.5, and this time I want it to join to my existing hexagon, like so. So now we've kind of done the first 7.5. The next thing to really do then is to work on our shaft and then basically work towards our thread. So overall diameter is M12. So if you know the metric system, it's going to be 12 mil. So again, click on the circle, face, new sketch, circle diameter. Remembering that we're taking a whole diameter, so edge to edge, 12 mil. Finish the sketch, up to extrude, insert the middle, going to push it up 100 millimeters, make sure it's on join, select, and there's our shaft element here. Last thing to do is we have the thread which goes from the top all the way back to 30 mil, and the rest is just a uncut shank. So what I'm going to do here is go to create, put a thread on, and choose the outside cylinder, so the edge. Just select it in here, untick full length because I don't want it to go all the way down to the face. Put my length as 30 millimeters. If you've done the shaft the right size, it should pick up as 12. You can obviously then select if you've got 0.75, 1.5, 1.25, or 1. So I'm just going to stick with 1.75. Pretty much a standard thread course. You've got classifications as well, so if you want to do classifications fit and whether it's left hand or right hand as well. So if you click OK, that'll give you a graphical representation of the thread. The thread does not exist, it's just a graphical representation because essentially a thread is a secondary machining type. So you use a machine to input the thread in, or you could use a simple tap or die, depending if you're doing obviously external or internals. For me, however, though, I go back into the menu, so I'm going to right click on the feature, edit my feature. Actually, I'm going to choose model, and then OK. And what this will do is then graphically change it into a physical model, so I could actually now select the helix. So if I want to actually build an assembly model, I've got the full element there. So for most people, this would then be your 100mm bolt M12. You could say that as part of your toolbox. However, if you notice on the edges here, it has actually got a slight cut from the machining process, which I don't have on my hex bolt. So if you're going to do like a 3D print, or you're going to do a representation of your physical item, you might want to add that bit in. So what I'm going to do is go to the front view. If your front view looks like mine, so you've got the edge coming through the front datum plane, okay, what you want to do is spin your part around to the right hand side so you have a nice flat edge. Create a new sketch. I'm not going to click on the part to isolate it to that element, I'm just going to click on the grid. That'll then select the right hand plane. And what I'm going to do is I'm going to draw a line into the corner, so it's really good to sort of try and get your grid aligned. So you could either click on, I'm going to draw a line up. Try and remember to get something, so I'm just going to do 0.25, go back to line, draw on the other way, again try and get the same numbers again, so 0.25, and then I'm going to use the create the arc tool, a 3-point arc, and choose the top of my structure. Bottom, I want that to be tangential, so it should come up with a circle with a line. It does on the bottom right hand side there. Click, and what I'm going to do now is finish that sketch off there, so I have like a sketch on the outer perimeter of my part. what we're going to do is we're going to cut this away. So to use the revolve cut, I need something to pin around the axis. So I'm going to go click and destruct. They go all the way down to axis through cylinder. Click on the cylinder. Okay, and this bit's an axis line you can see now down here, which goes all the way through my part. So now when I come on to revolve, I'm going to select my axis, which is the middle. I'm going to select my profile, which is going to be sketch number 1. That one there. And what you'll see now is if I come around and I take the view, this will provide a cut everything that's on that red ring there. So it'll do a little nick of the overall part. Now, if you pan around and you look, it's not particularly great as when you compare to the drawing. Actually, it's kind of larger. So what I'm going to do is I'm going to go back to my sketch number 4, edit my sketch, pan and zoom round. What I'm going to do is I'm going to change this feature here, move to 1. That should then take the width and height because they are linked under a constraint of horizontal and vertical. Finish that sketch. And then that should update, which it has done. Now when I pan round, I get that edge, it's just a 1 mil kind of revolve cut. Like so, you can obviously tweak it again. I could actually come back and say I prefer it more. Annoyingly, it will keep flicking around left to right, so you remember where you're going. You want to do sort of 1.5. Finish the sketch, it will automatically edit, then pan round. So 1.5 looks a lot better. Get a nice scoop and dome. It's near enough touching like it would do on a real bolt. That's it. So all you need to do now, if you haven't already saved, save it into your design or on workspace, and you can use this for future elements. So thanks for following along, and hopefully you found it useful on how to construct a hex bolt to the size of M12.